consider the function fn of x is cosine of 2x multiplied by cosine of 4x, and so on, up to cosine of 2 to the power of nx, where n is a positive integer. Determine whether fn is an odd or even function, just define your answer. By definition, an odd function is when function of negative x is negative f of x. It's odd. For example, x cubed. Even it's when function of negative x is function of x. For example, x squared, and for trigonometric, cosine it's even function. Cosine of negative x is cosine of x. For example, cosine of negative 30 is equal to cosine of 30 degrees, and sine it's odd. Sine of negative x is negative sine of x. For example, sine of negative 30 is equal to negative sine of 30 degrees. Tangent is also an odd function. So we need consider function of negative x. So we write fn of negative x becomes cosine of negative 2x multiplied by cosine of negative 4x, so on, cosine of negative 2 to the power of an x, and it is equal to cosine of 2x, because cosine is an even function itself, cosine of 4x, so on, cosine of 2 to the power of an x, and hence we get that it is equal to just the function. Hence it's an even function. The next, by using mathematical induction, prove that fn of x is equal to a given expression. And since n is a positive integer, the first possible value of n is 1, so let's consider for n is 1, f1 of x becomes, it's a general term, and we can see that it's just cosine of 2x, and from statement f1 of x is just substituting 1 for n, we get sine of 2 squared x, 2 to the power 1 sine of 2x, and it is equal to sine of 4x over 2 sine of 2x, and we need show that it is equal to just cosine of 2x, and we can see that 4x it's a double angle with respect to 2x, so we can apply double angle formula. Sine of 2 theta is 2 sine theta cosine theta, hence it becomes 2 sine 2x multiplied by cosine of 2x divided by 2 sine of 2x, and hence it's cosine of 2x as required, hence true for n equals 1. As the next step, we write assume true for n equals k, and just rewrite a given statement. So assume true for n equals k, and hence cosine of 2x multiplied by cosine of 4x, and so on, multiplied by cosine of 2 to the power of kx is equal to sine of 2 to the power of k plus 1x, 2 to the power of k sine of 2x. And the next we consider for n equals k plus 1. Hence the left hand side becomes cosine of 2x multiplied by cosine of 4x multiplied by cosine of 2 to the power of kx x, it's a term corresponding to n, is k, and is multiplied by cosine of 2 to the power k plus 1 x. It's the term corresponding to n is k plus 1. And it is equal to, and we can see that it is equal to this, so we can rewrite it as sine over 2 to the power k plus 1x over 2 to the power k sine of 2x, and multiplied by cosine of 2 to the power cosine of 2 to the power k plus 1x. And we need to show that it is equal to this when n is k plus 1. And we can see that it's sine of some angle multiplied by the cosine of the same angle, and we can again apply a double angle formula, and when we multiply by 2 the numerator and the denominator, we get that the numerator becomes sine of the double angle, so sine of 2 multiplied by 2 to the power k plus 1x divided by 2 to the power k plus 1 sine of 2x, and hence it's sine of 2 to the power k plus 2x divided by 2 to the power k plus 1 sine of 2x, and we can see that it is equal to this when n is k plus 1. Hence, true for n equals k plus 1. And conclusion, if true for n equals k, true for n equals k plus 1. Since true for n is 1, true for any n is positive integer. And the next, hence or otherwise, find an expression for the derivative of f(n) of x with respect to x. You can use this or this function, but definitely it's more useful to use this expression. And we can see that it's division of two functions, so we should apply quotient rule. And a quotient rule says that u divided by v derivative, this formula is given in a data booklet, v squared u derivative v minus u v derivative. So f(n) of x derivative is equal to, and we can see that it's a constant, so constant multiplied by a function is constant multiplied by derivative, so we can consider 1 over 2 to the power of n, and sine of 2 to the power n plus 1 x over sine of 2x derivative, and it is equal to denominator squared sine of 2 to the power n plus 1x derivative multiplied by just sine of 2x minus sine of 2 to the power n plus 1x multiplied by sine of 2x derivative, and it is equal to 1 over 2 to the power of n sine squared of 2x. Sine over 2 to the power n plus 1x derivative, it's a function of more complicated argument. We should apply a chain rule, and it says we use formula for the derivative of sine. It's cosine of 2 to the power n plus 1x. We keep the same argument, but we should multiply by the argument derivative. 2 to the power n plus 1x derivative is just 2 to the power n plus 1. So cosine of sine of kx derivative, it's k cosine of kx. Or we can apply the next rule that if it's a usual function which is given in data booklet, but if it depends on ax plus b, not just f of x, so its derivative just a derivative and keep the same argument. And multiplied by sine of 2x minus sine of 2 to the power n plus 1x, and again sine of 2x derivative, it's cosine of 2x, and multiplied by 2x derivative, which is just 2. It looks very similar to sine cosine of sum of difference, but since there are different coefficients, we cannot factor out them. Hence, these formulas cannot be applied here. And it's the required derivative. And the next shows that for n is greater than 1, the equation of a tangent to the curve y is fn of x at x is pi over 4 is given by, so equation of a tangent is mx plus c, where its gradient m its derivative of a function at the point where it is drawn, so its derivative at pi over 4. So let's consider this derivative at pi over 4. So it becomes 1 over 2 to the power of n, or actually 1 not required, sine squared of 2 multiplied by pi over 4, 2 to the power n plus 1, cosine 2 to the power n plus 1, pi over 4, and sine 2 times pi over 4 minus 2 times sine 2 to the power n plus 1 pi over 4 cosine 2 times pi over 4. And we can see that its cosine of pi over 2 is 0, so it disappears. Hence it becomes this divided by this, and we can see 2 to the power n plus 1 divided by 2 to the power of n, and hence it's just 2 in the numerator, and in the denominator it's sine of pi over 2, it's 1 squared, it's 1, and actually denominator is not required, so it becomes 2, and sine over 2 times pi over 4 sine of pi over 2, it's 1, so it becomes cosine, and it becomes 2 to the power 1 multiplied by 2 pi over 4, and we can rewrite it as 2 multiplied by cosine of 2 to the power n pi over 2, and let's consider, since n is greater than 1, let's consider when n is 2, we get 2 multiplied by cosine over what? 2 to the power of 2, 4 multiplied by pi over 2, it's cosine of 2 pi. When n is 3, it becomes 2 cosine of 8 pi over 4, which is 4n. N is 4, it will be 16 times pi over 4, which is 8 pi, and you can see that we get the same points. It's actually the same as cosine of 0, it's 1. So for it's 1 where for n is greater than 1. Hence it's just 2 for n greater than 1. So this equation of a tangent becomes y is 2x plus c, and we need c. To find c we need any point on a given tangent, and the only point on a given tangent is the point where it is drawn, and it is given that it is drawn at pi over 4, and it's a common point for the tangent and for the curve, so we can find corresponding y coordinate of this point if we substitute it into the function. So let's consider y coordinate, its function at pi over 4, and it is equal to sine of 2 to the power of n plus 1 pi over 4 divided by 2 to the power of n sine over 2x, so sine of 2 multiplied by pi over 4, and it becomes sine of pi over 2, it's 1, and numerator becomes sine 2 to the power of n multiplied by 2 and by pi over 4, it's pi over 2, and when n is 2, it's 4 times pi over 2, it's 2 pi, sine of 2 pi. When n is 3, it will be 8 times pi over 2, so we can see sine of 4 pi. When n is 4, we can see that it will be sine of 8 pi and so on, and the sine of n pi or k pi is 0, so it's 0 for any n greater than 1. Hence a point on a tangent is pi over 4, 0, and we substitute it to get c, so it becomes 0 is 2 times pi over 4 plus c, hence c is minus pi over 2, hence minus pi over 2, hence the equation of a tangent becomes y is 2x minus pi over 2, and multiply by 2 to get 2y is 4x minus pi, and yes, it's correct, 4x minus 2y is 4x minus 2y minus pi, yes, it's correct, minus pi is equal to 0, so it's the required equation of a tangent, and it's correct as required. And that's all for this question.